Okay, in this video, we're going to go over how to find the area of a trapezoid, a parallelogram, and a kite. Now, this is review for high school students, and actually it's Common Core for 7th grade geometry in the standard B6, but it's probably good to go over it because trapezoids, parallelograms, and kites are just a little bit unusual shapes, and they warrant some re-explanation, I think. Okay, so let's start with the trapezoid. Now remember that a trapezoid is a figure, a four-sided figure. It is a type of a quadrilateral that has one set of parallel sides. Okay? So you need to somehow indicate that the sides are parallel, all right? And that's what this these particular marks mean. Now, in order to find the area of a trapezoid, you need to know a couple of things. The area from the parallel sides to parallel side, okay, for example, that red line there, is called the height, all right? And that's important because it figures into the formula for the area of a trapezoid. Now, the side up here is called the base, and it's usually indicated by a little subscript, base sub 1. And this side down here we'll call base sub 2. And the formula for a trapezoid is equal to area is equal to 1/2 times the sum of the bases times the height. All right, so 1/2 sum of the bases times the height. Another way of actually just saying this, which is really exactly the same, is that the area is equal to 1/2 of the height times the sum of the bases. Okay. So for example, let's say, and you'll notice, by the way, that when I draw the height here, that I have pretty much formed a right triangle here, haven't I? And you can use your knowledge of right triangles and heights and sides and that sort of thing to determine what the height is if you need to, when you have like a figure like that, okay? Now let's go talk about the area of a parallelogram. Now remember that a parallelogram looks something like this. And a parallelogram has two sets of parallel sides. Okay? Now, as the same takes place in a parallelogram as it does in a trapezoid, you usually go from one of the corners, one of the vertices, go straight down, and again, that is known as the height. Okay? By the way, these sides are not only parallel, but they're also congruent, right? So the area for a parallelogram is base times the height. And just as in a trapezoid, these are the bases. Okay? This is called base 2, but it really doesn't make any difference. This could be base 1, this could be base 2. All right, so it's just 1/2 the base times the height. Just as long as you know what one of the bases are, you really have the length that you'll need for this formula. And finally, let's look at the area of a kite. All right, now remember that a kite has two sets of, let me say it again, that adjacent sides are congruent. There's two sets of adjacent sides that are congruent. So for example, this side and this side are adjacent sides and they are congruent. This side and this side are also adjacent and they are also congruent. Now, one of the interesting properties of a kite, of this particular kind of kite, by the way, there are other types of kites, but we don't have to talk about that at the moment, is that these lines that cut across a kite are called diagonals. Okay? And just like there is two different bases, there are also two different diagonals. And they're usually indicated by a sub letter, sub 1, and we'll call this one diagonal sub 2. Okay? And that is important because the area of a kite is equal to 1/2 the length of the first diagonal times the length of the second diagonal. Okay, so again, just real briefly, remember that this is called a trapezoid. And remember your definition for a trapezoid as one set of parallel sides. The area of a parallelogram and it's just base times height. Again, the height can cut into these kind of triangles. And finally, that the area of a kite is based off 1/2 of the two diagonals. Okay, I hope that was helpful.